Hello, my name is Benjamin Gerard. I am a postdoctoral researcher at the University of California, Santa Cruz. I completed my doctoral studies at the University of Victoria in British Columbia, Canada, working primarily at the National Research Council of Canada, also in Victoria. My main field of research focuses on planets around other stars outside of the solar system. When the Berlin Wall fell on November 9th in 1989, I was not yet born. I was born in 1991. As a child, I wanted to become a scientist, and it did come true. I had very supportive family and role models. Both of my parents are scientists, and just this past spring, I received my PhD in physics at the University of Victoria. The wall we're breaking with our research is to make instruments capable of detecting planets like Earth around other stars outside of the solar system, in particular, those that can support life. The challenge our project addresses is that current instruments are not yet capable of detecting planets like Earth around stars outside of the solar system, and this is because such planets are at best 10 million times fainter than their host star, making it very difficult to subtract the scattered starlight to that level of suppression. However, current instruments are able to detect planets like Jupiter around other stars that are at best 100,000 times dimmer than their host star. And so here we can see an image of a planet similar to that of Jupiter around the star 51 Eridani. The planet is labeled by the letter B and located near the red arrow. But we don't see any planets like Earth in this image, and again, that's because instruments aren't yet sensitive enough to subtract the scattered starlight to 1 part in 10 million. Our solution to this problem is a new technology called a coronagraph mask that, designed by myself and collaborators at the National Research Council of Canada, is able to subtract the scattered starlight to about 100 times better than current instruments are capable of doing. Our new coronagraph mask technology makes it possible to see planets like Earth that are at best 10 million times fainter than their host star around other stars outside of the solar system. Without this technology, current instruments can see gas giant planets, but are not able to see planets like Earth. The power of this technique is illustrated by a simulation of a before and after comparison, showing that scattered starlight in the image on the left can be subtracted to see a planet around another star that is about 100 times dimmer in the image on the right. The main application of this research is giving context to understanding where our solar system came from, how it formed, and whether or not there are other solar systems out there like our own. So understanding, are we alone, is a pretty essential question in our existence. And with this research, we're looking to see if there are other planets outside of the solar system that can support life. The main question in my mind that keeps me lying awake at night is, how well will this technique work? As we've not yet brought this technique to a telescope. Before I mentioned a simulation that showed promising results, but we're working very hard in the lab to develop this technique and consider all of the possible problems we might encounter at a telescope so it can be ready. My mother and father and extended family and friends are all very supportive of the work that I've been doing. It's a very exciting field that's rapidly evolving with new technology being invented, and I feel very lucky to have had the support to continue on in this field.